Hi students, in this video I am going to explain about Introduction to Laplace Transform and also discuss about Laplace transform of some elementary function. The Laplace transform is named after the French mathematician Pierre-Simon Laplace. He introduced this method in the late 18th century mainly while working on problems related to probability and celestial mechanics. Later, engineers realized that this method is extremely useful in electric circuits, control systems, mechanical vibrations, signal processing. Today, Laplace transform is a powerful tool in engineering mathematics. It helps us to convert differential equations into some simple algebraic equations. Basically, Laplace transform is a mathematical technique that converts time-based function into a frequency-based function to make calculations easier. That is, it will convert the time domain, t domain, to a complex frequency domain, otherwise we call S domain. That is, Laplace transform of f of t is denoted by capital letter f of s, that is a function of frequency S. Now let us learn about the definition of Laplace transform. The Laplace transform of a function f of t defined for t greater than or equal to 0 is given by Laplace transform of f of t is equal to f of s is equal to integral 0 to infinity e power minus st into f of t into dt. Here t denotes the time domain variable and s denotes the complex frequency variable. Now let us learn about Laplace transform of some elementary functions. Laplace transform of the constant function. Laplace transform of 1 is equal to 1 by s for s greater than 0. Let us prove this one. So we know that Laplace transform of f of t is nothing else integral 0 to infinity e to the power of minus st into f of t into dt. Now L of 1 will be equal to integral 0 to infinity e power minus st into 1 into dt. So what is integration of e to the power of minus st? It will be e power minus st divided by minus s and substitute the limits from 0 to infinity. Upper limit minus the lower limit is e to the power of minus infinity minus e to the power of 0 the lower limit divided by minus s. So e power minus infinity is 0 and e power 0 will be 1. So we will be having L of 1 as 1 by s. In general, we can write L of k as k by s, where k is a constant. For example, k is equal to 2. L of 2 is equal to, we will be having 2 by s. Now let us learn about Laplace transform of the power function t to the power of n. L of t power n is equal to n factorial by s to the power of n plus 1, where n takes values 0, 1, 2, etc. And also it can be represented as gamma of n plus 1 by s to the power of n plus 1. As we know that gamma of n plus 1 is nothing else n factorial. For n is equal to 1, L of t is equal to, it will be 1 factorial divided by s to the power of 1 plus 1, that is 1 by s square. Similarly, when n is equal to 2, we will be having 2 factorial divided by s to the power of 2 plus 1, so it will be 2 by s cube. Suppose n is a fraction, then I will be using gamma of n plus 1 by s to the power of n plus 1. Later on, we will do problems based on fractions. A Laplace transform of an exponential function e to the power of at is given by 1 by s minus a. For a is equal to 1, we have L of e power t is equal to 1 divided by s minus 1. When a is a negative 1, we have L of e to the power of minus t is equal to 1 divided by s plus 1. For varying a, we will be getting Laplace transform of the corresponding exponential function. Now let us learn about Laplace transform of sine and cosine function. Laplace transform of sine at will be equal to a by s square plus a square. Suppose if you take a is equal to 1, then Laplace transform of sine t will be equal to 1 divided by s square plus 1 square, that is 1. Suppose you take a is equal to 2, then Laplace transform of sine 2t will be equal to, it is 2 divided by s square plus 2 square, otherwise it is 4. Similarly, Laplace transform of cos at is equal to s divided by s square plus a square. For a is equal to 1, we are having a Laplace transform of cos t as s by s square plus 1. For varying a value, we will be getting the corresponding Laplace transform of the cosine function. Likewise, Laplace transform of sine hyperbolic function and cos hyperbolic function is given as sine hyperbolic function will be a by a square minus a square, and cos Laplace transform of cos hat will be s by a square minus a square. For a is equal to 1, we have L of sine ht as 1 divided by a square minus 1, and L of cos ht as s divided by a square minus 1. Now let us learn about some basic properties of Laplace transform. For a and b as constant, Laplace transform of a into f of t plus b into g of t is equal to constant multiples come outside the Laplace transform. Means take a outside and b outside, and then take Laplace transform of f of t plus Laplace transform of g of t. That is Laplace of a sum is the sum of the Laplaces. That means Laplace transform is clearly a linear operator. For example, what is Laplace transform of 3t plus 5? So here the constant will be taken outside. So it is 3 times Laplace transform of t plus 5, 5 times Laplace transform of 1. So we know that by the formula of the elementary function, Laplace transform of t power n is equal to n factorial divided by s to the power of n plus 1. For n is equal to 1, we will be having here uh, L of t as 1 by s square. So it will be 3 by s square here. And similarly, L of 1 will be equal to 1 by s. So we'll be having it as a 5 by s. So Laplace transform of 3t plus 5 will be equal to 3 by s square plus 5 by s. Now let us solve some problems. Let us find the Laplace transform of sine h 60 plus 3 into e to the power of minus 5t plus cos 5t. It is equal to, using the linearity property, we'll be having it as Laplace transform of sine h 60 plus 3 times Laplace transform of e power minus 5t plus Laplace transform of cos 5t. Now using the formula, we know that Laplace transform of sine h 80 is equal to a divided by a square minus a square, and we know that Laplace transform of e power et is equal to 1 by s minus a, and Laplace transform of cos et will be equal to s divided by s square plus a square. Now using these formulas, we will be having here Laplace transform of sine h60, substituting a is equal to 6. We have 6 divided by a square minus 6 square plus 3 times, substituting a is equal to minus 5 in this formula, we have 1 by s plus 5, then plus, substituting a is equal to 5 in this formula, we have Laplace transform of cos 5t as s by s square plus 5 square. Now let us go for the second problem for finding Laplace transform of cos square 2t. So we are not having a direct formula for Laplace transform of cos square. So here since we got a square, we have to convert this into the linear form. So we know that your cos square theta formula is equal to 1 plus cos 2 theta divided by 2. So if we use this formula, we will be having this as L of 1 plus cos 4t divided by 2, because theta is equal to 2t here. So now taking the constant outside, we have 1 by 2 into Laplace transform of 1 plus Laplace transform of cos 4t. So we are having the same above formula. What is L of 1? L of 1 will be equal to 1 by S. And what is L of cos 4t is substituting our A is equal to 4 in this formula. We have S divided by S square plus 4 square. Similarly, let us go for another problem. Finding Laplace transform of sine cube 2t. Again, directly finding Laplace transform of cube function is not available, but we know that sine cube theta is equal to 1 by 4 times 3 sine theta minus sine 3 theta. So here theta is equal to 2t, so this can be written as Laplace transform of 1 by 4 times 3 into sine 2t minus sine 3 into 2t, that is 6t. So taking the constant outside, so it is 1 by 4 into, even we can take this 3 also common outside, 3 by 4 into Laplace transform of sine 2t minus 1 by 4 into Laplace transform of sine 6t. And we know that Laplace transform of sine 80 formula will be A divided by S square plus A square. In this formula, we will substitute A is equal to 2. We will be having 2 divided by A square plus 2 square minus 1 by 4 into 6 divided by A square plus 6 square. Now let us go for finding Laplace transform of t to the power of 2. So we know that Laplace transform of t power n is equal to n factorial divided by s to the power of n plus 1. So when substituting n is equal to 2, we will be having 2 factorial divided by s to the power of 2 plus 1. It is equal to 2 factorial by s cube. Suppose we are having Laplace transform of t to the power of minus half. Our n is equal to half. Means we cannot use this formula. Instead, we will use the gamma function. We know that n factorial is gamma of n plus 1 divided by s to the power of n plus 1. So n is equal to minus half. When we substitute in this formula, we'll be having gamma of minus half plus 1 divided by s to the power of minus half plus 1. That is equal to gamma of half divided by s to the power of half. But we know that gamma of half is equal to under root of pi. So the final answer will be root pi by root s. Suppose we are having, we have to find Laplace transform of t to the power of half. That means here n is equal to half. So it is gamma of half plus 1 divided by s to the power of half plus 1. We know a relationship in gamma function, like gamma of n plus 1 is equal to n gamma n. So here n is equal to, we got it as half. So it will be half gamma half divided by s to the power of 3 by 2. And we know that gamma of half is root pi. So it will be root pi divided by 2 into s to the power of 3 by 2. Thank you.